I'm going to use one of the biggest decisions facing my wife and I in retirement to highlight some lessons for AI leaders on what is arguably the core skill in developing AI solutions. And it is a core skill that for most of you, I suspect you have not heard talked about in the context of AI.
This is AI for Leaders by AI Leaders. Practical, to-the-point content helping you drive results with AI. Here's Chris and Frank.
Hi, and welcome to the AI Leadership Podcast. I am Frank Strickland. Hope your new year is getting off to a great start. As Chris and I reflected on the past year, 2023, we did a rough tally and we wound up training 2,500 senior leaders and senior executives on the leadership of AI programs, projects, people, and technology. And one of the consistent questions that we received from a large percentage of those that we trained, offline, people would ask us, how's retirement? What are you doing in retirement? Are you really retired? Various questions about retirement. So I did an episode last week. You can check that out on our YouTube channel if you did not see it, or on Apple or Spotify, wherever you get your podcasts. I did an episode on how I think about retirement from an analytical perspective, and specifically a question that was asked of me by my portfolio manager when I was about 50, that fundamentally reshaped how I think about retirement and fundamentally reshaped, caused me to frame this analytical approach to retirement. And I talk about that, and I talk about three implications of that approach. So you can check that podcast out if you have not heard it. We were going to have a segment, an episode with Chris on his perspectives on retirement. We're going to do that next time. We got some feedback on the first episode from a master data scientist and a very seasoned AI leader who said, wow, that was a really helpful episode. I listened to it with my spouse. And both my spouse and I found it really interesting. And that prompted an idea for a follow-on episode in which I'm going to use one of the biggest decisions facing my wife and I in retirement to highlight some lessons for AI leaders on what is arguably the core skill in developing AI solutions. And it is a core skill that for most of you, I suspect you have not heard talked about in the context of AI. So I'm going to set up the decision that is facing my wife and I, and then I'll pivot to talk about the core AI skill, come back to kind of how that decision is working out for my wife and I. And then we'll finish up by giving you some practices, some tips derived from this episode and this content that hopefully you can apply in leading AI people and projects. So let's go first to outline the decision that is facing my wife and I and the beginnings of our approach to that decision. And that decision is, where are we going to live in certainly chapters 14, 15, and 16 of our lives? Now, this metaphor, chapters 13 through 16, you can go back and listen to the episode that I alluded to, the first episode on retirement, and I will explain what those mean and how that came about. Let me just say this. If you think about the diminishing returns curve in your mind, and it is a very helpful analytical way to think about your lifespan, when you get into your 60s, probabilistically, you are up on the plateau of the diminishing returns curve. You're up on the flat part where the curve is starting to roll over. And what comes after the plateau is the decline. And You can go out to the Eastern Shore if you live near the DMV, or you can go out to the Pacific Coast. You can howl at the moon, but the tides are going to come in and out. And so I've had people tell me when I have talked about retirement and talked about analyzing my lifespan and my wife's and my lifespans in this way, oh gosh, Frank, this is very morbid. Um, it's not morbid. It is pragmatic. It is pragmatic. And so my wife and I are facing a decision problem, and that decision problem is where are we going to live? A lot of what you and I do as AI leaders is we attack decision problems with artificial intelligence. Problems like, should we bring the aircraft in for depot maintenance now, or should we wait until it's regularly scheduled for depot maintenance? Is this case a high probability of fraud such that we should pull it out of the mainline case processing and have our fraud claims unit look at it, or should we allow it just to go through the regular case processing? Are the Russians about to invade another neighbor, or is this just a snap exercise that the Russians, and it goes on and on and on. So AI deals regularly with big decision problems. And when dealing with decision problems in your own life and in your work, I know what the default and kind of the knee jerk approach often is, and that is it defaults to looking at options immediately. And I'll just relate this to AI, something that I think will resonate with all of you. When ChatGPT came out in November, and people really began to become attuned to large language models and generative AI, and lots of vendors, not just OpenAI, but Google, Microsoft, Meta, lots of COTS vendors, as well as open source models were beginning to proliferate. I can remember Sundar Pichai, the CEO of Google. I can remember the senior vice president for business development, Microsoft, and several other kind of big vendors being interviewed on Harvard's IdeaCast, on Bloomberg, on other major media outlets, and their advice was, okay, here's what we suggest you do, Mr. Government, Mrs. Government, Mr. Business, Mrs. Business. Here's what you need to do vis-a-vis Gen AI. Just pick one of these models and get started. Now, that at some level is not bad advice. I could put that within the project types, the 4 project types that Chris and I talk about. One of those project types is experimentation, and certainly picking a large language model and doing some deliberate, it's not just pick one and try, but doing some deliberate, some problem-focused experimentation, that is a good way to get started. But when you have a decision problem, you need to do more than just start plunging in and thinking about options and rummaging around in options and kind of, well, pick one and get started. In my wife's and my case with this decision on where we're going to live, we have looked at North Carolina and various places in North Carolina. We have looked at an area in Delaware. We have thought about Maine. Frankly, we've thought about Canada. Not we, have thought about Costa Rica. So we have done some rummaging around in options, but we want to think about this very consequential decision for us, because one of the things that, back to that diminishing returns curve analogy, as we're up on the plateau and we begin to approach the decline, or what I would call chapters 14, 15, 16, we're going to need to be in a home that is conducive to the time period when the synovial fluid in our knee joints has largely gone away. We're at a 3-level colonial right now, and trooping up and down steps is fine right now. Thankfully, we're both in great health. We work out. We're in good shape. But we're not going to stay on the plateau forever. So, very consequential decision. And the question is, how do we approach that decision? What can we learn from this core, I would argue, core task, core work area, and how AI solutions get developed? What can we learn from that in making this decision? And then what lessons can you take from that? So let's pivot then to that discussion of what is arguably the core work area in artificial intelligence solution development. So when you look practically at the work of AI solutions development, and we get beyond all the hype and we get beyond all the conceptual casserole, the dialogue that tends to surround AI a lot, um, especially for leaders who have not grown up as data scientists, as AI practitioners, which is true of the vast majority of leaders that need to affect AI solutions. We want to look very practically now at the work of AI, and I will make this argument for kind of the core, the kind of bare metal skill that is underappreciated. I rarely hear anyone talk about it, but your best AI practitioners and your best AI leaders will understand this. So first, if we take an AI solution development, it is a multidisciplinary team. We know that, right? So there are multiple disciplines. Data science is arguably the core discipline. Not arguably, data science is the core discipline. But you must have software engineers, you must have IT people, computer scientists, system architects, et cetera, et cetera. Designers, for all my designer friends out there, you must have user experience designers for a big enterprise scale AI solution. So it's a multidisciplinary team, but the core of that team and the core discipline is data science performed by data scientists. Now, fundamentally, what is that? Fundamentally and practically, um, data scientists are training and testing AI models given a data set and for a given problem. And just, for those of you who haven't spent a lot of time leading data scientists at the team level, here is the reality. Data scientists want to build models, and the more complex the model, the better they're going to feel about it. I recently watched the movie Air, which was a historical dramatization of Michael Jordan's family and Michael Jordan being recruited by tennis shoe companies and eventually signing this, history-making deal with Nike. And that then prompted me. I grew up. My high school time was in the '70s. I grew up playing basketball. Loved basketball. And so that took me to the Netflix series that was made on Michael Jordan's career, The Last Dance, and I watched all of those episodes for about the fifth time. Really good if you've not seen that, even if you're not a rabid basketball fan. Just kind of a fantastic and well-told story, and a lot of leadership lessons in there, both pro and con, that you can consider. But some of you will remember, I think probably many of you will remember, if you were of sufficient age that you were tuned into commercials in the 1980s, late 80s, early 90s. That song, that jingle. Sometimes I dream that he is me, like Mike. I want to be like Mike. Well, there wasn't a similar jingle being made by the other members of the team: Scottie Pippen, Dennis Rodman. Imagine your children. I want to be like Dennis. No, John Paxson, Steve Kerr, et cetera, Bill Cartwright. It was Michael. It was the superstar. And that is a rough analogy, but a good one for the way you can think about data scientists and complex modeling. The data scientist, in the vast majority of cases, wants to be engaged in the modeling activity the data engineering, the conditioning the data, the building the data pipelines. Yes, it has to be done, but it's really dog work. It's blue collar data science work. It'd be nice if someone else would do that. I want to build a model. I want to train test a model, and the more complex the model, the happier I'm going to be. And so it's again kind of roughly, if the basketball thing meant nothing to you, and if you're in the national security community, it's sort of like, if your son or daughter goes to the academy or goes to ROTC and wants to become a pilot, um, they're generally not going into pilot training thinking, I want to pilot a refueling tanker. No, that's generally not what they're thinking. They're generally, I want to be a fighter pilot. I'm going to be in the next Top Gun movie. And so that, while somewhat tongue in cheek, gives you a pretty good characterization of what data scientists learn to do. They learn to code models. A data scientist uses code. Python, R, Java, Scala. They use code, software code. They use statistics, advanced statistics, and they use computing. Those are the three tools on the tool belt: code, statistics, and computing, to train and test these models. And the more complex the model, the happier the data scientist is going to be. That can obscure what Chris and I would argue is arguably the foundational competency for the best data science practitioners and, frankly, for the best AI leaders. And that is, as one of my master data scientists once said to me, Frank, I am an analytical problem solver. I am an analytical problem solver. If you think about model development, you can kind of envision a triangle in your mind's eye. And the workflow, and I'm not talking about the project workflow, but I'm talking about the hands on the keyboard and the intellectual workflow, especially early on in the early phases of a project that is happening with the data scientist and data science team, consists of defining a business or mission problem that is relevant and is suited to AI. So it's relevant to the business or the government department or agency. And in relevance, meaning I'm going to invest the resources required in order to build and deploy and maintain a model to address this problem. So it has to have sufficient relevance in the business or mission, and it has to be suited to AI. Not every problem, obviously, is suited to AI. There are plenty of problems that the government certainly could be tackling right now that just involve getting non-value added work out of business processes. And yes, you can use AI to do that, but there are many other tools that you could use: robotic process automation, or just good old software applications where you're not pulling on the AI lever. So relevant business problem that is suited to AI, and then data that is aligned to that, and a modeling approach that fits, a modeling approach that is suited to the problem you're trying to solve, and the available data. Well, that requires analytical thinking and analytical problem solving to get in and start mucking around in the data. The formal term you'll hear your data scientists use, if you're not a practitioner, if you haven't grown up as a practitioner, the phase of work is called exploratory data analysis. You can just think of it as mucking around in the data. I've got the data up in front of me. I'm looking at it. I'm running some basic statistics. I'm trying to understand kind of how many features am I looking at here? How big is this data set? Is this data labeled? Is it labeled properly, et cetera, et cetera? So I'm going through this exploratory data analysis phase, and I am trying to refine my initial problem statement, because oftentimes the initial problem statement needs to be refined. Oftentimes it's just a hypothesis or a very broad question. Quick bad illustration. I heard a a very smart, and I would consider him a friend. Hope he would consider me likewise. Technical engineer, senior executive in the intelligence community, stood up a few years ago in front of an industry group of about 300 in the room, regarding AI. And he said, I don't want to hear any more talk. No more talk about what our problems are. We don't need to talk about what our problems are. We know what our problems are. We need solutions. Well, that was okay, I guess. At that point, he was trying to put an emphasis on solutions. And certainly Chris and I want to put a big emphasis, obviously, on getting AI deployed at scale, integrated into major programs. But he said, we know what our problems are. Our problems are China, North Korea, Iran, nuclear weapons development in Iran, et cetera. And he named a bunch of big countries and big topics. You don't need to be an AI practitioner, a data scientist, to just intuitively know we don't have an AI model for China, and we're not going to build one. Or Iran, or even Iran's nuclear weapons program. We have to refine, and oftentimes you can think of refining really as just kind of the way you would think about formulating a thesis statement. If you've done a grad thesis, or if you kind of think about a doctoral thesis, you're not looking for this wonderfully comprehensive problem statement. No, you've got to get down to a defined and refined problem statement that can be modeled usefully with AI and with the available data. And so that skill of analytical problem solving, analytical thinking, the ability to, I'll call it, close that triangle, define that problem that is relevant to the business and suited to AI, to condition available data to get the right data relevant to that problem, and then to take a modeling approach and train and test a model. Closing that iron triangle requires a lot of just foundational analytical thinking. And so your best data scientist, they don't have to use this term, but they won't think of themselves chromosomally as I'm a model developer. Anybody can go to a boot camp, especially with the tools that are available today, and learn to code a model. Much, much fewer can close that iron triangle in a meaningful way that results in a model that gets deployed at scale and has big impact on the enterprise. It is Chris's superpower. It is what I have seen him do in multiple defense, intelligence, and civil government environments. And so that analytical problem solving gets down, again, one further level to just good, solid analytical thinking. And so with that, I want to pivot back to this decision problem that my wife and I have, which is where are we going to live and how are we going to make that decision? And I'll make some points about analytical thinking before wrapping it up with some tips and practices for you in leading people.
If this content is of use to you, we encourage you to subscribe to our YouTube channel and give this episode a like. If you're listening to this episode on Apple or Spotify, please take time to give us a 5-star rating. And if you have a moment, leave us a quick review. You'll find more resources like this podcast and training courses at our site, aileaders.com. Let us know what you think. We value your feedback.
So let's pivot back to how my wife and I approached and are approaching this decision, because we haven't made the decision yet, but we've begun our analytical problem-solving attack on this decision problem. First, I said we had looked at some options. Now, if you have especially a defense acquisition background, and if you've got a little snow on your roof or on your beard, if you're a little long in tooth, if you've been around working for a few decades or even a couple of decades, you might have this immediate instinctive reaction. That's the wrong approach. We don't look at options first. We don't look at solutions first. We need to get the requirements defined. Requirements always precede the solutions. Blah, 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 blah. That is wrong. As George Day, a Columbia B School prof who wrote to me the best single volume in terms of competitive business strategy, market-driven strategy is the name of the book. In the prologue, he talks about this argument that often emerges about whether a business should have, customer pull or technology push. He calls it a distinction without a difference. It's a feckless, it's a rhetorical argument. It's nonsense, and especially nonsense is something as complex as AI and closing that iron triangle that I talked about. That's a very iterative process, and so you don't want to shut yourself off from thinking about solutions, but you also don't want to just plunge in, and again, I'm not picking on these vendor leaders, but your total strategy can't be amounted to, I'm going to pick one and get started. So you need a way of thinking about this and working it in an iterative way where you are looking at solutions, but what you're trying to do ultimately is refine your criteria in an analytical way. Lest you think this thread that I'm pulling about AI, data science, analytical problem solving, and just good analysis skill, good analysis discipline, lest you think in your mind that is straightforward, I'll give you this challenge, and please let me know how it works out. Chris and I have done it a number of times. Take your team or one of your teams or teams, or if you don't have a team, just take a random group of professionals and give them a 3x5 card, have them sit quietly by themselves and ask them to write down in about a minute their definition of analysis, and then put those definitions up and look at them. And what you're going to find is a wide degree of variance in those definitions. And ultimately, what you're going to find is that pretty much every professional has a conceptual sense of what they mean by analysis and what analysis means. They don't have a good practical sense. And if you're going to lead something like AI, I would argue you don't have to have grown up as a data science practitioner. I didn't. Again, a data scientist, by definition, is using code, advanced statistics, and computing to test and train models to derive insights from data that's relevant to the mission problem. That is what a data scientist does, full stop. So if you're not able to use code, Python, R, Scala, Java, etc., you are not a data scientist, full stop. So you don't have to be a data scientist. You don't have to have grown up as a data scientist to lead it, I would argue, and I am one of many illustrations of that. But you do need to be very solid in your understanding of leading AI, and you need to be at least a competent analyst. And I don't mean that in the sense that most people would use the term analyst and they think about a junior person. I'm talking about someone who has good, solid analytic problem solving skills. So let's talk about analysis for just a second and this decision for my wife and I. Two words that I would expect to see in a definition of analysis, a practical definition of analysis, is decomposition and differentiation. I have a problem. It is a whole, and I want to decompose that problem into constituent parts, but I want to put the parts into categories that are differentiated from one another. Now, let me use again all analogies, and metaphorical language tends to fall down, but let me use one that I think will resonate with the vast majority of you. Most of you have had hands-on experience with this. You go out and you get a 2,000-piece puzzle, and you bring the puzzle home, and you've got a big dining room table, and you dump the puzzle pieces out on the table, and what do you immediately do? The whole has already been decomposed for you. It's decomposed in the box. You're going to begin to take the puzzle pieces and sort them into differentiated categories. And in many cases, the differentiated categories are going to have subcategories. So let's say that your puzzle has a lot of blue sky associated with it, but some of that sky has white fluffy clouds. And so you have puzzle pieces that are a combination of blue sky and white fluffy cloud. And then you have puzzle pieces that are just blue sky, and you have puzzle pieces that are just white fluffy cloud. Well, you're going to make 3 piles, but those piles are going to be close together. And you can think of that as a category, sky, that has 3 subcategories underneath it. If the puzzle has a train with a locomotive and cars, the locomotive itself is going to have subcategories. And you're not going to sort the pieces such that you have pieces of the sky mixed up over here with pieces of the locomotive and vice versa. That's not how you assemble a puzzle. And almost all of you have assembled a puzzle in this way, which is why I'm using this analogy, or you can imagine it. You've watched someone do it. You're doing that with analysis. You're taking the problem of the whole and you're decomposing it into its parts, and you're differentiating between those parts and the subcategories. So you're differentiating between the categories and the subcategories. Now, why are you doing that? So that you can understand the component pieces and you can look at them not only in your mind and thinking about reframing, but you can look at them in isolation as the individual parts. And you can look at them clearly because I've not muddled the sky up with the locomotive pieces. I'm looking at them very clearly. There is good mathematical reason to do this if you were building a math model, and we will put some things in the show notes that will point you to a document on using quantitative data types and scales for decision making. It is a document that comes out of a defense acquisition journal back in the mid 90s, but still very relevant. And it treats the differences between nominal, ordinal, interval, and ratio data and what mathematically you can do and not do with that type of data. And if you work in this space long enough, if you work in the space where big decisions are being made, there is not a small probability that you will come across someone using weighted criteria in a way that is mathematically invalid. And this paper will help you to understand that. It not only gives definitions, but it gives some good illustrations. We'll also have a short blurb and point you to something on collinearity, which gets a little bit more mathematically complicated. It's a part of linear algebra. Some of you will resonate with that from your math experience in college and maybe on the job. But just know that there's a solid mathematical underpinning for this differentiation among the categories and the pieces. But for you, whether you're going to quantify a decision or not, it just tremendously helps you with clear thinking, so that you're looking at the problem. I can see the whole. I want to see all of the categories and all of the pieces that I've decomposed. But I want to see them clearly. I want to be able to differentiate between the categories and differentiate between the pieces. Try to use this if you're in the government when you're writing a statement of objectives or statement of work, because so many of them are frankly just a dog's breakfast. Or If you do sort of write a dog's breakfast statement of work or statement of objectives, um, give credit and expect the vendors who respond to your RFP for clarifying the thinking. Here's a good illustration of this. Chris won what at the time was the largest AI job in one of the companies where we were leading, and it was with a big civil agency. And in the process of evaluating the proposals, they came back with questions, kind of a standard process. Okay, the government's read your proposal, the government comes back with questions. And there were dozens and dozens of questions that came back, and they were just in an ordinal list: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And they went on dozens and dozens. And in looking at the questions, in taking the whole and decomposing and differentiating, what Chris and the team realized is, okay, there are 100 plus questions here, but they really fall into 5 big categories. See, they've differentiated, and now they're reframing into 5 categories. And by reframing in that way, by decomposing, differentiating, then reframing in an analytically solid way, they were able to give much clearer and compelling answers to the questions. And the government actually congratulated Chris and the team on taking that approach, because it was helpful to the government to clarify the government's thinking when the answers came back with that type of analysis and synthesis. Just a very foundational skill. So how did this relate to what my wife and I did? And then we'll pivot to some tips for you in applying this in your day-to-day AI leadership. I said my wife and I had looked at some options. That's fair game. But we're not just going to pick one and get started. And we're not going to sort of make a decision of this consequence by just kind of rummaging around options and stray voltage conversations and, wake up one morning with a feeling that we ought to go to North Carolina. That's, too many business and government decisions are made that way. And you know what I'm talking about. You don't make big consequential decisions that way. You're looking at options in part to help you refine your criteria. And in refining the criteria, effectively what you're doing is you're decomposing the decision problem into its constituent parts, and you're categorizing those parts. So without getting into too much detail, because my wife and I have just got started, one exercise we did over dinner after we ordered some champagne and an appetizer, and then subsequently a good bottle of wine and a multi-course meal. And we had a very relaxed conversation. But we literally took 5x8 cards and we sat quietly, which as 2 introverts is fairly easy for us to do. And we just thought quietly to ourselves about what our individual criteria are. We jotted those down. Then we exchanged the cards and we had a discussion about the criteria. Let me make a quick point about this as it relates to how you lead AI solutions development that goes beyond the technical discipline of just solid analytical problem solving and good solid analysis. A thing that beginning that way does for my wife and I is it takes this very large consequential decision, and yes, we're beginning to work it in an analytically rigorous and valid way, because we're going to scrub those criteria. We're going to ensure that we get good differentiation. We're not going to have the puzzle pieces mixed up. We're not going to have collinearity for those who have a math background. We could quantify this set of criteria we eventually come up with, and I probably will. My wife will have none of that, even though she's an engineer and has a technical background. She's not going that far. But we will get a set of solid categories and criteria defined that we are going to use in helping guide us in making this decision. That's a very solid analytical approach to this decision problem. But there's another benefit. By doing it this way, we had an opportunity to sit and listen to one another, not just define the criteria, but express the thinking and the feelings that are behind each one of those criterion. If you think about it from the standpoint of a senior leader and a leader team, what we were doing at the very personal level is building coherence or building oneness between us as we move toward this tremendously consequential decision. And having these sort of analytically rigorous discussions and listening to one another helps you to work what I call the socio-technical aspects of any AI solution development. It's not just a technical problem. You know that rhetorically. You need to know that in the way you need to exercise that you know that in the way that you lead. There are relational aspects to one of these big complex solution developments. There are emotional aspects, there are political aspects. And so by having this sort of approach, you're able to work that oneness, that coherence. So that is what my wife and I did. Again, you might think, wow, that's a really nerdy approach. No, my wife's not nerdy. But it is a massively important decision, just like the decisions that government and businesses are making every day around AI. It's a tremendously consequential decision. And so we're going to take a solid analytical approach to it. And by taking a solid analytical approach, we're really sharpening the core foundational skill on which AI and data science sit, and that is analytical problem solving. So let's wrap up, and I'll offer a couple of very specific practices, tips that you can use in leading your AI teams and leading AI solutions. So let me offer you 3 tips that you can use in applying this content and what you've inferred from this content, this episode, in your AI leadership. The first is just recognize that analytical problem solving is foundational to good data science work. Because that's not necessarily taught in all of these data science boot camps. What's taught is, here's the Jupyter notebook, here's Python, let's take random forest, here's a set of data, train a model, test a model, boom, move on. So recognizing that you need to build people who have solid analytical problem solving skills is an important first step in teaching that to your leaders so that you can ask questions like, how are we doing that? How are we building that? One of the immediate practical applications of recognizing it is asking questions on a team, on a job, like, talk to me about how you've refined the business problem. How did that work? And talk me through the refinements that you've made to the business problem. Analytical problem solving. The second tip is focus on the concept of lift when you ask that question about refining the business problem. And what I mean by lift is, if I am performing at this level today, X, what level am I trying to move the enterprise to, the business unit to, the agency mission unit? What am I trying to get in terms of improved performance by training, testing, and deploying this model? That's lift. Baseline performance is not something that Chris and I have found that all AI teams have a really good grasp on. Again, and I'm not, um, I'm not picking on data scientists. Love them; they're my tribe. Um, but this kind of analogy that I made about be like Mike, tongue in cheek, but there's a serious reality within it, and that is I've come out of these boot camps, I've come out of undergrad, I've come out of grad, I've got a data science grad degree, data science undergrad degree. I want to code up some complex models. I want to get after it on a convolutional neural net, big hairy model, and I want to train it. I want to test it. That's what I want to do. And it is easy for things like what's the baseline performance that we're working against to not be thought about or be pretty conceptual or even obscured. So what is the baseline performance and what lift are we anticipating getting? Because that lift, in effect, is the return on the investment in developing the model. And then the third thing that you can do in building analytical problem solvers and good solid analytical thinking within AI solutions is the development of domain knowledge, or what some of you in commercial might call industry knowledge. Again, if you go back to that iron triangle, at the pinnacle, most important element, a relevant business or mission problem that is suited to AI. You cannot define that without domain knowledge. And data scientists have learned and are learning how to use code, statistics, and computing to train and test models to derive insights from data that are relevant to the business or mission. Well, they're not learning domain knowledge, and most of them are working in a domain for the first time. Now, they're fully capable of learning domain knowledge, but you as the leader have to be out on point, and you have to be creating a culture and a practice of learning domain knowledge. I'll give you two illustrations from just the past week that I encountered that really encouraged me. I was sitting with a CEO of a substantial company yesterday, and he and I were having a conversation about whether we're going to enter into a coaching relationship where I would be providing some executive leadership coaching to him. And he said at one point, unsolicited, in a very sincere way, Frank, throughout my entire career, one of the most consistent elements of what has been a burning passion for me in my career is continuing to learn about my business, continuing to learn about myself, continuing to learn about my people, continuing to learn about how to lead better. You as the leader need to create that culture. And one of the most important things you do in creating that culture is being a learner yourself. And so practically what you can do is another example from this week from a master data scientist who once worked for me. I learned that he had gotten the biography of a retired Army general, happens to be my father-in-law, but that's irrelevant to the tip or the practice. But he had gotten the biography of my father-in-law, Lieutenant General retired Julius Beckton, and he'd gotten a copy of that autobiography for the members of his team, and they were all going to read the book together and discuss the book, because there's great domain learning about the Army in that book. And so reading books, watching movies together, there are many other ways. Chris and I talk about it in our book and in our courses. There are many other ways that you can promote domain knowledge learning, but that is the third tip or the third practice. If you want to build analytical problem solvers, you need to be helping them develop domain knowledge. So recognize the importance of analytical problem solving and developing the skills. Ask questions about the business problem and lift, and develop domain knowledge. Three very practical things that you can take out of a spousal dinner and discussion about where we are going to live when we no longer have synovial fluid in our knee joints. So hope, as always, that was a practical value to you as AI leaders. Chris will rejoin. He's been traveling for about 3 weeks. retirement equals flexibility, which is a great blessing. But he will rejoin next time, and we'll wrap up this series on retirement, where I will be interviewing him about his perspectives on retirement and how that relates to AI leadership. And then we will pivot back to other topics in leading the integration of AI into major programs, developing quality results in AI projects, and leading AI people in technology. So for this episode, thanks very much for listening. Appreciate you.